Hi everyone, Assalamualaikum and good day. Today we are going to continue with the chapter 7, which is limit. Okay, so for this chapter we have 5 lectures. So the first lecture we are going to focus on 7.1, the subtopic limit. Okay, at the end of the lesson, students should be able to state limit of a function f(x) as x approach to a given value a. So we write down this as limit of f(x) as x approach to a equal to L. This is the value of limit lah. And then for b, we have students should be able to state the basic properties of limit. Okay. Definition of limit. If the function f(x) approach to L when x approach to a. So f(x) approaching to L when x approach to a certain value a, then we say that the limit of f(x) when x approaches a is L, and it is written as limit f(x) when x approach to a equal to L, where a and L an element of a constant. In dealing with the concept of limit, we are not interested in the value of f(x) when x equal to a. So this is the value of y lah. But we are interested in the behavior of f(x) as x come closer and closer to a value of a. So let's see how it goes in a type of graph. So this is our graph of f(x) and this is the value of x, which is a. So we are not looking at the value of f(x), but we are looking at the value of the behavior of the graph when it's approached to a. So from the right side, so the function f(x) will approach to L, to a value of L. Okay, and then from the left side, so we write down it as limit of f(x) when x approach to a positive. Why positive? Okay, because it's come from the right side here. Okay, and then from the left side, as x approach to a, the function f(x) also approaching to L. So from the left side, we put x approaching to a and negative at the top. Okay, so we call it as x approach to a from the left side. So it also going to value of L. So let's see some example. Find limit of x squared plus 1 as x approach to 0. So we have x equal to 0, but we want to find the behavior as x approach to 0. So from the left and from the right. So left side of 0, we have negative 0.001, negative 0.25. So it's going to the left. We take any value on the left and then it's approach to 0. So if suppose we take negative 1, so the value, the next one nearer to 0 is negative 0.5 and so on. Also the same from the right side. So we can take 1 and then as it approach to 0, we have 0.5, 0.25, 0.001. Okay, so what we need to do, we just calculate all these value for f(x) equal to x squared plus 1. So what we have for negative 1 is equal to 2. For negative 0.5 equal to 1.25. For negative 0.25 equal to 1.0625. And for negative 0.001, it's equal to 1.0000001. Okay, so it's from the left as x approaching 0 from the left. And then when x equal to 0 from 1, so we can see that from the left, this limit of x squared plus 1 as x approach to 0 from the left is approaching to 1. Okay, it's going to 1, it's nearer to 1. And then for x equal to 2, we get f(x) equal to 2. For x equal to 1, we get f(x) equal to 2. For x equal to 0.5, we have 1.25. When x equal to 0.25, we have 1.0625, and when x equal to 0.001, we have fx equal to 1.000001. Okay, we can see that as x approaching from the right, the value of fx also will approach to 1. So when x equal to 0, we get 1, right? So it's actually limit of x squared plus 1 when x approach to 0 is 1, because both from the left side and right side is equal to 1. Okay, so how to find the limit? Okay, actually we just directly substitute the value of x approach to. So let's here we have x approach to 0. So what you need to do is substitute 0 into the limit. So if they ask you to find the limits directly. Okay. So let's see the graph of x squared plus 1. So this is our graph. So we can see that from the left side, the value of y when x approach to 0 is approaching to 1. And from the right side also, x approach to 0 from the right side, the fx will approach to 1. So both are approaching to 1. So we have the limit of x squared plus 1 when x approach to 0 is equal to 1. So this is our answer. Okay, now let's see this example. So find limit of x squared minus 9 over x minus 3 when x approach to 3. So if we use the substitution, we try an error to see what is the value of fx approaching to when x approach to 3. Here, we take value of, before 3 from the left side, we have 2.8, 2.9 and 2.99. And then from the, we calculate the value, we get 5.8, 5.9, 5.99, and suddenly at 3 it's undefined because it's 0 over 0. We cannot have the value over 0, right? And then the right side of 3 we have 3.2, 3.1, 3.01. So the value also 6.2, 6.1 and 6.01 is actually approaching to 6, but at 3 it's undefined. So both of these value 5.99 and 6.01, although fx is not defined at x equal to 3, when we substitute the value of 3, we get 0 over 0. So and value over 0, the limits depend only on the values from the left and right of fx, where x are close to 3, not at x equal to 3. So what we can say from this both value, that fx is actually approaching to 6. So how can we calculate it without substituting any value from the left side of x and the right side of a? Left side of a and the right side of a. So let's say this 3 is a, right? So if we cannot find it directly, so how do we do? Do we need to find out like this every time, every single time? So there are steps to find the value of limits when this case happen. Okay. So let's see properties of limit. So limit of a function fx as x approaches a exists if fa is defined. It can be obtained by substituting the value of a into the function. So this is how we try to find the limit. We just substitute the value of a into the function. So for example, if fx equal to c, where c is a constant, then the limit of fx of as x approaches a is equal to limit of c as x approaches to a. So it's a constant directly, the limit is also a constant. For example, limit of 5 as x approaches to 3 is 5. The second one, if fx equal to x, then limit of fx as x approaches to a equal to limit of x as x approaches to a, which is equal to the value of a itself. Okay, so limit of x as x approaches to 4 is equal to, what is the a? A is 4, so it's equal to 4. And the third one is if fx equal to x to the power of n, where n is a positive integer and more than 0, then limit of x to the power of n equal to a to the power of n as x approaches to a is equal to a to the power of n. So we just have to replace the x as a. So let's say, for example, limit of x cubed as x approaches to 4. So we replace the x as 4. So we get 4 to the power of 3, which is equal to 64. So what you need to do is just replace the value of x with a to get the limit. Okay, let's do some example. So find the limit of the below functions. Limit of 3x squared plus 4 as x approach to 2. And then for second question, it's limit of 2x minus cube root of 16x when x approach to 4. And then we have limit of x cubed over absolute x as x approach to 3. And limit of 2x squared plus x minus 3 all over x cubed plus 4 as x approach to 3. So let's do example A. So limit of 3x squared plus 4 as x approach to 2. What we can do is just directly substitute the value of 2 into the function. We have 3 multiplied by 2 squared plus 4. So it's 4 multiplied by 3 is 12 plus 4 is 16. So this is the answer. Directly substitute the value. Okay. Exactly. So another method is actually we separate it because it's limit. Sorry. Let me use another color. So it's a limit. This is equivalent to limit of x approach to 2 of 3x squared plus limit as x approach to 2 of 4. So this is a constant directly equal to 4. And this one we have x. So 3 of 2 squared. So 3 of 2 squared plus 4. The same thing as here. So we can do separate or directly. Okay, so for question B, we have limit of 2x minus cube root of 16 x as x approach to 4. Okay, so calculate it. So substitute the value. We get 2 of 4 multiplied with cube root of 16 multiplied by 4. So it's like 4 multiplied 16 multiplied by 4 is 64. So cube root of 64 is equal to 4. And 2 multiplied by 4 is 8. 8 minus 4 is equal to 4. So we have the answer here. Okay, let's do example C. So limit of x cubed over absolute x when x approach to negative 3. Okay, we have negative here. Okay, so what we need to do is just substitute the negative 3 into the function f(x). So we have negative 3 cubed divided by absolute negative 3. So negative 3 cubed we get negative 27. And negative 3 will have, yes, we will have 3. For negative absolute negative 3 is equal to 3. This one is negative 27. That's why divided by 3 equal to negative 9. And then for question D, limit of 2x squared plus x minus 3 all over x cubed plus 4 for x approach to 3. So substitute the value of 3. We get 2 of 3 squared plus 3 minus 3 divided by 3 cubed plus 4. So this is 0. So we have 9 multiplied by 2 is 18. 27 plus 4 is 31, so 18 over 31 as the answer. Okay, so for additional properties of limit. So the following additional properties is usually applied when substitution is not applicable. Means that when we substitute the value of x approach to a, that value a, we substitute a, we don't have the answer, the final answer. It might unavailable or unknown or incorrect. Okay, so these properties can be also used even though the substitution applicable. So example, if limit f(x) equal to 3x when x approach to 2 and limit of gx equal to 8 when x equal approach to 2, complete the example using the property. So if c is a constant, then limit of c of f(x) equal to c multiplied with the limit of f(x) itself. So we can take out the c. For example, limit of 3 of f(x) as x approach to 2. So we know already limit of f(x) when x approach to 2 is actually equal to 3. So for 3f(x), we don't know what is f(x), right? So we can use the property. So we take out the 3. So it will be 3 multiplied with limit of f(x) when x approach to 2, which is that value we know already, which is equal to 3. So 3 of 3 equal to 9. And then for number 5, limit of f(x) as x approach to a exists, then limit of square root of f(x) as x approach to a is equivalent to square root of the limit f(x) when x approach to a. For example, limit of square root of 2gx, so we can write down as square root of limit of 2gx as x approach to 2. And we know the limit for gx, so we can take out this 2, so it will be square root of 2 of limit gx as x approach to 2. So it will be equal to square root of 2 multiplied by limit of gx as x approach to 2 equal to 8. So 2 of 8 is 16, so equal to 4. Square root of 16 equal to 4. So the next one is, if limit fx as x approach to a exists, then the limit of fx to power of n as x approach to a is equivalent to limit of fx as x approach to a all to power of n. So we find out the limit for fx first. So let's say we have the limit of fx to power of 5. So we can say that it is equivalent to limit of fx, the limit itself to power of 5. So what is limit of fx as x approach to 2? It's equal to 3. So it will be 3 to the power of 5, which is equal to 2 for 3. And then the next one is, if limit fx as x approach to a and limit of gx as x approach to a exists, then the limit of additional or subtraction between the function, we can separate into the limit additional or subtraction of the limit of each function. Okay. So for example, limit of gx minus 2 fx as x approach to 2 can be written as limit of gx as x approach to 2 minus with the limit of 2 fx as x approach to 2. So the constant can be taken out. So we know the limit of gx equal to 8. So 8 minus 2 of limit of fx, which equal to 3. So 8 minus 6 equal to 2. Then, if limit of fx as x approach to a and limit of gx as x approach to a exists, then the limit of fx multiplied by gx as x approach to a can be separated into multiplication between the limit of fx and limit of gx. For example, limit of fx square multiplied with gx can be separated into limit of fx square. The square can be put out in outside of the limit, multiplied with limit of gx. So we know limit of fx equal to 3. So 3 squared multiplied by limits of gx, which is equal to 8. So 3 squared multiplied by 8 is 9 multiplied by 8, which is equal to 72. And the next property is, if limit of fx when x approach to a and limit of gx as x approach to a exists, then the limit of fx divided by gx is equivalent to limit of fx as x approach to a divided with limit of gx approach as x approach to a, where limit of gx must not equal to 0. Why? Because any number divided by 0 will be undefined. So limit of 2 fx divided by gx can be written as 2 limits of fx as x approach to 2 divided with limit of gx as x approach to 2. So 2 multiplied by 3 divided by 8, which is equal to 3 over 4. Okay? So let's do some example 3. Given that limit of fx equal to 4 as x approach to 1 and limit of gx as x approach to 1 is equal to 1. So evaluate the limit of hx as x approach to 1 if limit of x approach to 1 fx plus 2gx over hx is equal to 2. So we can separate by using the properties. This limit of fx plus 2gx over hx can be written as limit of fx plus 2 times of limit of gx divided by limit of hx. Okay, so what we don't know is limit of hx. Let it as the subject. So we rearrange it, and limit of fx is equal to 4, limit of gx is equal to 1. So 4 plus 2 of 1 divided by limit of hx equal to 2. So limit of hx is equal to, yes, it will be 4 plus 2 divided by 2, which is 6 over 2, which is equal to 3. So we now have the limit of hx, even though we don't know what is exactly function fx and gx. Okay, so it's really simple. For the basic of limit, we just have to substitute the value and use the properties. Now, this is the basic one. We will go more deeper on the next lecture. So don't worry about the first lecture. Just directly substitute the value. Okay, so that's all for this lecture. See you guys next week after the holiday. Okay, use your time wisely. Okay, don't just enjoy, but please rearrange, and maybe you can plan ahead because we have the UPS3 coming up, and also the assignment. Okay, so that's all for today. Thank you.